Hello, this is Cho World. Today, we will take an in-depth look at the AI scaling hypothesis proposed by Anthropic and the possibility that AI at or beyond the level of human experts could emerge in recent years. AI has advanced at a revolutionary pace, to the point where some say it has jumped from high school level to college level, and then to PhD level performance. The AI scaling law is the concept that an AI model's performance can continue to improve with more data, larger model parameters, and increased computing resources. This insight became a reality between 2014 and 2017, with Baidu's speech recognition research, the advent of GPT-1. In other words, if you train a model bigger, longer, and on more data-difficult tasks, such as semantic understanding and reasoning, gradually becomes solvable. In the past, while handling text at the sentence level might have been feasible, many believed paragraph-level tasks were too difficult. However, by increasing the scale, models can now handle even more complex structures beyond paragraphs. Of course, there is the question of whether this scaling can be pushed without limits. For instance, the amount of high-quality data available on the internet is finite, and there are concerns about the recycling of repeated or duplicated data, as well as AI relearning its own generated text. However, there are cases like AlphaGo Zero, which generates its own data through self-play, and approaches such as the chain of thought reasoning model, which can create synthetic data to circumvent data shortages. There is also a projection that if we are currently using clusters valued around $1 billion, pressimize 3 times, by 2027, we might see clusters worth $100 billion, about 100 trillion KRW, become a reality. A concrete indicator of how much AI capabilities have actually improved is the Swebench coding test. At the beginning of this year, the accuracy rate for professional coding tasks was around 3–4%. In just 10 months, it increased to 50%. According to Claude Sonnet 35, this means AI is producing meaningful code in complex real-world software projects. Engineers now say that not only beginners, but also experienced professionals can save time. Anthropic predicts that it might even reach 90% accuracy within a year, and emphasizes that it is steadily approaching the level of human engineers. Anthropic's business strategy is not merely to produce the highest performance model, but rather to lead the entire industry toward a safe and ethical AI competition, under the banner of a race to the top. To this end, they are focusing on mechanistic interpretability, which involves reverse engineering the internal activation patterns in order to understand how the model arrives at its decisions and responses. Co-founder Chris Olah is leading this field. They have also conducted experiments like the Golden Gate Bridge example, where they highlight neurons corresponding to specific concepts to dramatically alter the model's responses. This suggests that the model is not merely a black box. It has an internal structure with consistent logic and patterns. Anthropic's Claude models are broadly divided into Opus, Sonnet, and Haiku. Opus has the largest number of parameters and the highest performance, but is also the slowest and most expensive. Sonnet is a medium-sized model aiming for a balance between performance and speed. Haiku is a small, lightweight version that is fast and cost-effective, but offers relatively lower baseline performance. Interestingly, over time, smaller models have continually surpassed the performance of previous larger models, indicating a generational shift. There are already results showing that Sonnet 35 outperforms the previous generation's Opus 30, certain areas like coding. A lengthy process is required to release these new models. During the pre-training phase, Massive training is conducted over several months, using tens of thousands of GPUs, followed by fine-tuning with RLHF human feedback reinforcement learning, constitutional AI to ensure the model is safe and useful. They also work with Anglophone AI safety institutes to examine high-risk scenarios, such as CBRN threats. Afterward, the process involves evaluation and debugging by both internal and external partners, which inevitably takes time for version updates. From the user's perspective, there are often complaints that the model feels slower after updates. Anthropic cites two main reasons for this. First, the model's weights may not have changed at all, but minor adjustments like A/B testing, system prompt tweaks can alter user perception. This is partly a psychological effect. Initially, it feels groundbreaking, but as time passes, users discover more of the model's limitations on their own. Second, the model can be overly sensitive to subtle differences in prompts, causing significantly different answers. This illustrates that modern AI is not a perfectly controllable tool. Ultimately, the core issues are how rapidly AI will grow and how we can manage that growth safely and operate it with transparency. Anthropic is optimistic that in 2 or 3 years, models exceeding the performance of doctoral-level experts will emerge. They also warn that if power is concentrated in a single company or group, enormous harm could result. They argue that instead of treating the technology itself as a black box, we must ensure interpretability, transparency, and ethical control frameworks. This is directly tied to the race to the top strategy, which involves competing to see who can minimize risks and fulfill social responsibilities the most effectively. Going forward, we must continue to watch and prepare for how these colossal models will transform human society. The primary reason AI is viewed as a form of power is that its potential influence can already create massive ripple effects across multiple domains. For example, imagine a well-capitalized corporation or government agency developing and operating a colossal model exclusively. In that case, they could exert overwhelming influence over not just economic policy, but also social decision-making as a whole. Such concentration of power is not confined to the tech domain alone, because the information or recommendations AI generates could sway public opinion and cultural trends. Ultimately, there is a concern that the political landscape and even citizens' perceptions could be steered in the direction a particular power group desires. Furthermore, because colossal models require huge amounts of funding for research and development, those without substantial capital may find it difficult to even gain access. This goes beyond the technology gap and deepens social disparities, ultimately increasing the possibility that only a powerful minority group will monopolize the power provided by AI. This is precisely the point that Anthropic is concerned about. AI clearly has the potential to make the world more efficient. If a particular company or government gains excessive control, it could freely manipulate enormous wealth and information, potentially causing irreversible harm. This gives rise to the concept known as the race to the top. It means that AI development should be carried out in a safer and more responsible way, by guarding against monopolistic operation of extremely large models and strengthening interpretability and fairness. The goal is to minimize the risk of power abuse. Saying that AI becomes power essentially means that crucial resources in human society, information capital and control, can be concentrated in a single hand. In this process, individuals or groups that become marginalized may increasingly be excluded from decision-making. Therefore, how AI is developed and distributed is directly tied to the question of who is allowed how much power. This leads directly to the problem of AI power concentration, which is one of the greatest concerns in modern society. Ultimately, saying that AI is inherently power means that humanity's future can vary significantly depending on who controls and governs this technology. It is necessary to establish safeguards to prevent concentration in the hands of certain forces and to share technology in a transparent manner. Without such efforts, AI is at high risk of becoming a tool for a small group of powerful individuals, rather than benefiting all of humanity. Let's talk about the model bashing process conducted inside Anthropic. Over 1,000 employees deliberately break the model or induce unexpected situations like a real battle simulation. They look for weaknesses in the model and check where meaningless refusal responses arise. Although it's hard to prevent everything perfectly from a software quality validation perspective, it's an extremely intensive stress test. Now let's emphasize the broad use of evaluation methods. Anthropic runs a wide variety of test sets, numbering in the hundreds, to meticulously evaluate whether the model excessively repeats certain words or unnecessarily refuses requests, among other things. For example, there was an evaluation item that specifically monitored the model from repeatedly using the same expression, and thus harming the user experience. However, if you block one expression, the model may switch to another expression, causing similar issues. So endless refinement is needed. This slide points out that such internal review processes resemble typical product development cycles. After large-scale internal testing, the verification step proceeds through external users, or ASFB, testing, and if necessary, contract specialists are hired to examine specific scenarios. Still, some odd refusal responses continue to appear. So, the process is iterative, and improvements are ongoing in the long term. This slide mentions Claude 4.0. It's not easy to announce a detailed development roadmap, but it's clear that scaling will continue. It is emphasized that a much more powerful model could appear within a few years, and while its name is not decided, the recognition that such progress is inevitable is highlighted. Let's look at how responsible scaling and the ASL AI safety level standards are set. The concept of catastrophic misuse aims to prevent extremely dangerous issues, such as when AI is used for cyber or biological attacks. Another axis, autonomy risk, refers to situations where the model acts independently in ways that differ from human intentions or refuses requests excessively. Understanding why these two factors are important makes it intuitive why responsible development is essential. Let's explain the ASL levels in detail. ASL 2 is set at the current model level to prevent the direct provision of risk information beyond what Google provides. ASL 3 is for preparing against a time when the model becomes sophisticated enough that entities like non-state actors could misuse it. Hence, security and filter systems must be significantly strengthened so that knowledge about biological weapons or nuclear-related information is not too easily leaked. ASL 4 and ASL 5 evaluate whether AI could cause national-level risks or autonomy issues at an even higher level. This slide discusses when ASL 3 and ASL 4 might occur. Opinions vary within the company. Some suggest it could be next year, or even by the end of this year. Ultimately, it depends on how quickly the model's performance advances, and because it's changing rapidly, preparation is essential. The ninth slide covers AI evolving into a multimodal agent. Unlike in the past, when it only could respond via text, it can now read computer screenshots, click directly, or input via keyboard, controlling multiple programs as if it were a real person. For instance, it can open Excel and input data, or search for information on a website, gradually automating more and more tasks. However, if used maliciously akin to a hacker, it could manipulate systems or carry out illegal activities. So it's risky to leave it without safeguards. This concerns AI regulation and safety frameworks. There are limits to purely voluntary safety measures, which is partly why legislation like SB 1047 is being discussed. In the broader framework, if all companies do not follow the same guidelines, even a single entity's negligence could endanger the entire society. However, excessive regulation could stifle innovation, so governments and companies must work together to find a balance. Let's explore Dario Amode's background at OpenAI and why he founded Anthropic. He jointly led core technologies such as the GPT series RLHF and model interpretability research. During that process, there were differences in major directions, such as how much emphasis to place on safety principles and how to pursue commercialization and corporate partnerships. In the end, he decided to become independent and establish Anthropic to realize a new vision that pursues both safety and expansion. Now let's look at the concepts of RLHF and constitutional AI. RLHF adjusts the model to human intentions by having humans directly compare and evaluate its outputs for correction. Constitutional AI takes it a step further, designing the model so that it can read agreed-upon principles or clauses and adjust its answers on its own. Both methods ensure that the model doesn't run out of control without limits, while also preventing it from issuing unnecessary refusals. The essay machines of Loving Grace sheds light on a positive scenario for how AI may unfold. For instance, in medicine and biology, there's a projection that innovations once thought possible, around 2100, could be advanced to between 2027 and 2032 at current speed. Although many risks remain to be addressed, this is a concrete example that shows how attractive the future could be once those risks are overcome. Now let's take a closer look at innovation cases in the biofield. AI can simultaneously replace the experimental design and result analysis of numerous researchers or even simulate clinical trials, potentially leading to a breakthrough reduction in drug development time. Of course, regulatory procedures and safety verification on actual patients are absolutely necessary, so not all processes can be completed overnight. However, the fact that processes that used to take decades can now be reduced to just a few years suggests that the practical value of AI could be maximized. Lastly, the core message is that the opportunities and risks brought about by this technology must be managed in a balanced way. It's not just about developing quickly. It's about scaling up in the safest and most transparent way possible. It emphasizes that proper regulation and governance are necessary to safely pave the way for breakthroughs that can truly change society beyond the minor errors or misuses we see today. As a result, AI is a means of enhancing humanity's collective potential, but it requires everyone to approach it with a responsible attitude.